polar form of complex numbers. Okay. Join my class, contact number is given, and each course costs you 10,000 rupees. Advanced mathematical research concept cleared. Like my channel and subscribe. So today we are going to study complex number, and a very important topic in complex number is polar representation of complex number. So let's see what is polar representation of complex number. So draw x-axis, then draw y-axis, and their point of intersection is called O. Okay. Now let's consider a point P which is 1, 0. So in Cartesian coordinate system, we represent any point as an ordered pair, that is x, y. So here x is 1 and y is 0. Y is 0 means that the point lies on x-axis. That's why y is 0. So this point is at a distance 1 unit from origin. Now this point P can be represented as a complex number, we know. Okay. Now its distance from origin is 1 unit that I have shown. Now let's draw a circle that is passing through point P. Now since this circle is passing through point P, its radius is 1, and we know that throughout its course its radius will remain 1. So r is equal to 1 here. Let's consider another point, that is Q. Now what will be the coordinate of Q? The coordinate of Q will be any, let's assume that this Q is any general point. So we can represent its coordinate by x, y. Now how we obtained Q? So we obtained Q by rotating point P by an angle theta. Okay, we obtained Q by rotating P by an angle theta. Okay, so this angle is theta. So we can say that point Q is also a complex number. Okay, now how we can represent this complex number? Now let's use the notation. Now use the pen here. So how we can represent the complex number here? We know that the complex number Z, let's use some good color here. So we know that Z, a complex number, can be written as x, that is the x coordinate of the point, plus iota, that is the imaginary component of the complex number, that is y. So any complex number can be represented in that form, x plus I times y. Now how we can represent this in an Euler form? Now here what happened, that point P has been rotated, by an angle theta, and the distance of point P from origin is 1, and the distance of Q from origin is also 1. Let's call this as r, the distance of point Q from origin, which is equal to 1. Now how we can represent point Q in polar coordinate system? So that is equal to r times e raised to iota I times the angle by which the point P has been rotated, that is equal to theta. Okay. So once again, come here. Z can be represented as x plus I times y. Now here you can see that we are also representing this complex number as r times e raised to I times theta, and that representation is polar coordinate representation. Now you know that how we obtain the polar coordinate representation. Now here what will happen? Let's apply. Now we know that point P can also be represented as a complex number, which is equal to r times e raised to I times theta. Now here r is equal to 1, because we know that here r is equal to 1. Okay, now e raised to I times theta. What is the theta here? Now what will happen, that the theta will collapse at the point P. theta will collapse at the point P, and theta at point P is 0. So that will become 1 into e raised to 0. Okay, so e raised to 0 is 1. So we can say that my complex number z is equal to 1 plus 0 times I. So we can say that point P is completely real because its imaginary part is 0. Now if we rotate the point P counterclockwise, then what will happen? We obtain a point Q whose ordered pair is x and y. Now the imaginary part is coming into picture, and also the real part is already there. So how we can write this complex number? So we can write this complex number z as x plus I times y. That can also be represented as e raised to I times theta. Now e raised to I times theta, how that can be represented? That can be represented as cos of theta plus I times sine of theta using the famous Euler formula. This is called as the Euler's formula, your Euler's notation. Let's call this as the Euler's notation. So how a complex number is represented in Euler form? So it is simply that the point P has been rotated counterclockwise by an angle theta. And what is O to P? O to P length is r. So we represent point Q as a complex number as r times e raised to I times theta. R will tell the magnitude of the complex number, and theta is called the angle that this complex number makes with x-axis. Now let's delete all the points here and move forward. So the complex number z can be represented as x plus y times I, and in polar form we can represent z as r times e raised to I theta. Now again, consider x-axis and draw y-axis. The origin is O. Now point P 1, 0, which is at a distance 1 unit from origin. Let's draw a circle. Again a point Q whose general coordinate is given as x, y. Now how we obtain the point Q? We obtain point Q by rotating point P by an angle theta. Okay, so this is the angle theta, and the distance of point Q from origin is r. The r is also called as the modulus of complex number, and theta is called the argument of the complex number. So let's write it. So here I am writing theta is called the argument of complex number z. So here what is z? Z is my complex number, that is x plus I times y in rectangular form, and that can be written as r times e raised to I times theta. Okay, and what is r? R is called the modulus of complex number. Modulus of complex number z. And how we write r? So modulus of complex number r can be represented as square root of x square plus y square. Okay, so let's move. So in rectangular form we can write complex number z as x plus y times I, and in polar coordinate that can be represented as r times e raised to I times theta. Okay, now from point Q drop a perpendicular onto the x-axis, and let's assume that this perpendicular touches the x-axis at point M. Okay, now the projection of r onto the x-axis will be equal to cosine theta. Why it is cosine theta? Because again we can see that here r is equal to 1. Actually x can be represented as the projection of r onto the x-axis, so that can be written as r times cosine of theta. And since r is equal to 1 here, we can write x is equal to cosine of theta only. Okay? So x can be written as cosine of theta. Similarly, y can be written as what? Y can be written as sine of theta. Now we can write our complex number as here z is equal to x plus y times I. So here x can be written as, what is my x? X is equal to cosine of theta. So here it will come cosine of theta. And what is my y? It is I times y. And y is my sine of theta. Okay. So we can write this complex number as cosine of theta plus I times sine of theta. And using the Euler notation, Euler's notation, what we can write, cos theta plus I times sine of theta, that can be written as e raised to I times theta. Okay. Now if here r is equal to 1, if r will be 2, then 2 will come here. Here it is r times this. If it is 2, then it will become 2 times e raised to I theta. If it is 3, then it will become 3 times e raised to I theta. If it is 4, then it will become 4 times e raised to I of theta. So what is the meaning of that? Now r is equal to 1 here. It may be possible that we could have another concentric circle where r will increase, okay? So here another circle can be there. So if another circle is coming into picture, so what will happen? R has increased from 1. So R can be 2, then R can be 3, then R can be 4. So as the value of R increases, the radius of the circle increases, okay? So what is the modulus of the complex number? It is simply the distance of a point from origin. Okay, so let's move. Now you have understood what is argument of complex number, what is modulus of complex number. So let's move forward. Now, how we can write the modulus of complex number as a mod of z, and that is given as a square root of x square plus y square, where x is equal to r times cosine theta. Here we have mentioned that our x here is given as the projection of r, so that is equal to r times cosine of theta. And what is my, so x is equal to r times cosine theta. And what is my y? Y is given as, just see y is given as r times sine of theta. Here r is equal to 1 because we are considering a unit circle with radius 1. Okay. So again I am highlighting it, y is equal to r times sine theta. These are the projection of r onto the x-axis and y-axis respectively. So again we can write our complex number as, we have seen that it is equal to z is equal to x plus I times y. What is my x? R times cosine of theta. And what is my y? R times sine of theta. Taking r constant, what we will get? Taking r outside, we get r into cos of theta plus I times sine theta. Now this very particular term, let's come here and erase all. And we can say that this very particular term is called as what? Not this. Okay, let me just delete it. This very particular term is called what? So this is called as r into e raised to I times theta, Euler notation. Okay, so now we came to know that what is the polar representation of the complex number. So let's move forward. Yes, so this is called as a polar representation of the complex number. So what is this my r? R is my modulus of the complex number. Modulus of complex number. And what is my theta? Theta is called as the argument of my complex number z. Or this is also called as a modulus of complex number z. I think you must got up to this point. So for all the detailed classes, what you have to do is that you have to join my coaching classes, online tuition or coaching classes. It has been highly curated to suit your need, and it is highly engaging. So I request to all the students that please join the live classes by paying a nominal fee, okay? That will transform your concept. So we can see that any complex number z can be written as r times e raised to I times theta. Any problem so far? I don't think. If you have any problem, please comment. So again, consider x and y axis. Again, consider a point which is at a distance r, and its inclination is theta with respect to axis. Draw a perpendicular, and the projection of r. This is just a revision. So after each classes, I will provide a complete revision of what we have learned so far. So projection of r onto the x-axis is r times cosine theta. Projection of r onto the y-axis, that is called the y component, that is r times sine theta, that I have highlighted. Now any complex number z can be written as x plus I times y. Now what is x here? Now what is x here? So this is just another way to think. So what is x here? We can see that x here is given as r times cos of theta. And what is y here? Y is given as r times sine of theta. So finally we obtained our complex number z as what? R times cos of theta plus I times r times sine of theta. Taking r common, so we can write the complex number as r times cos of theta plus I times sine of theta. And you know that cos theta plus I times sine theta can be written as what? It can be written as e raised to I times theta. So any complex number z can be represented as r times e raised to I of theta. So let me delete this and let's move forward. Form, the complex number can be written as x plus I times y. Z is equal to r times cosine theta plus r times I times sine theta. That is a polar form. And now taking r common, so taking r common, we can write cosine theta plus I times sine theta. And we know that the famous Euler's notation, cos theta plus I times sine theta, is e raised to I times theta. So finally we can write the complex number as r into cosine of theta plus I times sine theta, that is equal to r times e raised to I times theta. Now in the next class we are going to study about de Moivre's formula, and you will see that de Moivre's formula is only possible because we are using Euler's notation, e raised to I times theta. So you can see that we are having the purpose to transform the complex number from rectangular to polar form. Why? Because it will make a lot of complex number transformation easier, like multiplication, division. So we are going to study in the further classes. Please join my tuition classes so that we would be able to solve all the numerical problems and could able to penetrate deeper inside the syllabus. Okay, so thank you very much. If you have any doubt, please comment in this section and I will be very happy to respond to you. Okay, so now again the usual the request to you, please like and subscribe, okay, to my channel. Thank you very much. So this class has been brought to you by Advanced Mathematical Research. Like and subscribe. Our course cost is 10,000 rupees per course. Thank you.